Hi all. So let's start a marathon PYQ session on engineering mathematics. So first we start with linear algebra, and within that a subtopic of determinants is chosen, and I have selected some already previously asked questions on the topic determinants. Okay. So let's look at some problems. So this is the first problem. Okay, find the determinant. Is this actually a gate question? It's look a simple question. Actually, it's a simple question. So we need to calculate the determinant. That's the problem. Okay. So we can directly calculate this problem, but for uh, making it the simplification process or the calculation easy, we can do some row operations. Okay. So we can say R3 can be written as R3 minus R1 plus R2. Okay. So if we do that, we can get the resultant determinant of a matrix as the first row remains the same 1, 4, and 9. Second row is also remains the same 4, 9, and 16. Then third row is replaced with R3 minus R1 plus R2. Okay. So here R1 plus R2 for the first element, what we get? The 9 minus 4 plus 1, that is 9 minus 5, that is 4. Then second one is 16 minus 9 plus 4. 9 plus 4 is 13. So 16 minus 13, we get 3. Then third, 16 plus 9 is 25. So 25 minus 25, 0. So we get this one. Okay. So I think we can calculate on this matrix itself. No further reduction is needed. Since it's a direct problem, we can do the calculation on this itself. Okay. So we can do along this row. Okay. Along this row. So we can say determinant equal to 4 into this is 4 element is third row and first column, that is minus 1 raised to 4, that is 1. So we can take positive value 4 into, then we have to remove this row and row and column corresponding to the element 4. So we get 4 into 16 minus 9 into 9, then minus 3 into 16 minus 4 into 9. Okay. So we can 4 into 416 is 40 plus 24, 64 minus 81 minus 3 into 16 minus 36 is 30 minus 20. So 4 into 64 minus 81. So 70 minus 70 plus 60. So the final answer is minus 8. So there is actually nothing much to do in this question. We can directly calculate the determinant and the answer is minus 8. Okay. So from these four options, the correct answer is minus 8. Okay. So we can go to next problem. So the second question is, if determinant is given as this, and then which of the following is a factor of determinant? That's the question. Okay. So in this we need to find factor of determinant. Okay. Let's say in the options we can say C, A plus B, A minus B, A B C, and A plus B plus C. So when we analyze these rows, the first row is 1A BC, then the second row is 1B CA. Okay, here A, here B, here B, here A. C is common. So we can just assume or put value as A equal to, let's assume A equal to B. Let's put that. If A equal to B, we get determinant as 1, 1, 1. This column remains the same. A equal to B. So replace A with B. So B, second row remains the same. B remains the same. C. Then third column, BZ. Then CA. In case of A, we need to substitute B. So CB. Again, in case of AB, we can say it's B square. A is substituted with B. So here, if I substitute A equal to B, I get this line, this horizontal line, and this horizontal line is same. Okay, so these are parallel lines in a matrix. Okay, same with same elements. So when two rows are same, the determinant is 0. So A equal to B is a solution, or we can say A minus B is a factor of determinant. Okay, why? I will explain once more. When I substitute A equal to B, I get the determinant as this. Okay, here this row and this row is same, so the resultant determinant is 0. If I get the resultant determinant is 0 for A equal to B, that means A minus B is a solution. We can write like A equal to B can be written as A minus B equal to 0. So A minus B is a factor. So in this we can see the option B, that's A minus B is a factor. Okay, so we got the answer. So A minus B is a factor. Okay, actually determinants are all simple problems, but let's just begin with determinants and go on to other topics in the later marathons. Okay, so let's look into the third problem. The determinant of the matrix is, okay, we need to find the determinant of this matrix. Okay, this is a 4 by 4 matrix. So calculating 4 by 4 matrix determinant is tedious, right? So, but here we have some features in this determinant. So it will make finding that determinant easy. Okay, consider this row. Okay, when I consider this row, these three elements is 0. Okay, so I can calculate determinant along this row. So along this row, I will calculate the determinant. Okay. So the determinant equal to 2 into determinant of, I can say, this column and this row is removed. Then I need to find the determinant of this section. Okay. So 1, 7, 2, 0, 2, 0, 0, 6, 1. Okay. Now our next task is to find the determinant of this section. Okay. So here it is having, consider this column. Okay. In this column we have this one element and all others are 0 here. Okay. So we need to calculate the determinant along this column. Okay. So the first element is 1. Then I need to find the determinant of this section. So the final determinant is equal to 2 into, then 1 into determinant of 2061. So which is equal to 2 into 1 into 2, which is equal to 4. Okay. So the answer for this question is option A, 4. Okay. It's a very simple question. So we can move on to next problem. Okay. These are all problems selected for the subtopic determinants. Okay. So one should answer these type of questions. This easy questions under the linear algebra topic. So everyone should get full mark for this subtopic. Okay. So let's look at this problem. If A is any n into n matrix and K is a scalar, then determinant Ka equal to alpha determinant A, where alpha is. Okay, this is a direct question, but let me explain. Okay, so it is given that A is a n by n matrix. What does it mean? It is having n rows and n columns. Okay, then determinant of Ka, what does it mean? When an element, a scalar, is multiplied with A, that means all elements of the determinant is multiplied with K. Okay. So all elements of the row, okay, and column are multiplied with K. Okay. So I need to find the determinant of this Ka. Okay. Ka. So which can be written as, if I take K as a common element from first row, I can write 1K here. Okay. Then determinant of A. If I take 2K from the second row, I have to write K square. Actually, I have n rows. Okay. So we can write k raised to n into determinant of A. Okay, there's a property. Uh, let's say I will explain like this. A equal to, let's say, A, B, C. So A1, B1, C1, A2, B2, C2, and A3, B3, C3. Okay. If I multiply with K, Ka equal to Ka1, Kb1, Kc1, Ka2, Kb2, Kc2. Okay. So we need to find determinant of Ka. Okay. So okay. Here from the first row I can take K outwards. Okay. So K common. So I can write determinant A1, B1, C1. Here it is Ka2, Kb2, Kc2, Ka3, Kb3, Kc3. Okay. So similar way I can take this K. Okay. So it will be K square here. Okay. Again, if I take this K also, I get here K cube. The original matrix was 3 by 3 matrix. So I get K cube here. So in the given question, it's n into n matrix. So the answer will be K raised to n. Okay. So our answer is option C, K raised to n. Such a simple property, yet just explained how we can take one element common and write the determinant. Okay. So let's look at the next problem. Okay. We need to find the determinant of the matrix. Okay. This I think there is no much calculation needed here. The determinant of a matrix. Matrix is a 4 by 4 matrix given. So when we look at this type of matrix, this is a triangular matrix. Okay. Triangular matrix means in a square matrix, this is the diagonal of the matrix. Okay. On the upper side, we can see all zeros. Okay. In case of triangular matrices, either this upper side is completely zero or this lower side is completely 0. So either upper side or lower side is completely 0. We can say this is a triangular matrix. Okay. So finding determinant of a triangular matrix is very easy. So we just need to multiply the diagonal elements. Okay. So in case of finding determinant of a matrix of the form triangular matrix, we just need to multiply the diagonal elements. So the determinant here, the answer determinant is 1 into 1 into 1 into 1, which is 1. So our answer, final answer is option C, 1. Okay. So let's look at the next problem. Okay. These are all gate questions, gate previous questions. Okay. So the determinant of matrix given below is, okay, we have given a matrix and we need to find determinant. So here also we have to choose the row smartly. Okay. So let's look at this third row. So here only one element is non-zero. So let's take this row. Okay. So the determinant is equal to the element 1 here. This is from third row and fourth column. So 3 plus 4 is a odd number. 7 is an odd number. So negative 1 into determinant of, we have to remove this row and this column. So we get 0, 1, 0, minus 1, 1, 1, 1, minus 2, 0. Okay. So here also, when we observe this row, okay, we have only this element as non-zero element. So we can take determinant along this row. Okay. So we can write minus 1 into this element is first row and second column. So it's an odd number. 1 plus 2 is odd number. So we have a negative sign here. Negative 1 into, we need to remove this column and this row. So we get this minus 1, 0, 1 and 1. Okay. So minus 1 into 0, 0, minus 1. Okay. So we get into minus 1. So the final answer is minus 1. Okay. So our final answer to the question is option A, minus 1. Okay. So let's move on to next question. The determinant equals, okay, we have given a matrix and we need to calculate the determinant. Okay. So let's, Okay, so we need to calculate the determinant, right? So for that, let's do one thing. Okay, I will give one tip for this question. Okay, so here, if you see something like 1 1 1, something like that, uh, we can do one thing, like we can do row operations and make this one 0, this one also 0, so that we can calculate the determinant much faster. Okay, so for that, let's do some row operations. R1 equal to R1 minus R2, R2 equal to R2 minus R3. So we can rewrite this as R1 is R1 minus R2. That's 1 minus 1 0. Then R2 minus R3 is B minus 1, 1 minus B 0. Then 1, 2B 1. The third row remains the same. So we can calculate determinant along this column since there is only one non-zero element here. So we can write which is equal to this is the third row and third column. So we get positive value itself 1 into determinant of 1 minus 1 b minus 1 1 minus b. Okay, so which is equal to 1 minus b minus 1 b minus 1, which is equal to 1 minus b minus b plus 1, 1 minus b plus b minus 1, so which is equal to 0. So the final answer is nothing but 0. Okay, so I think everyone got the answer. So let's look at the final problem of today. Okay, so which of the following does not equal to determinant of this matrix? Okay, we have given a matrix. This is the matrix, and determinant of this matrix we need to calculate. And the question is which of the following does not equal? Okay, which of the following does not equal? That's the question. Okay, so here we have to check which of the following is not equal to this one. Okay, so to understand this, we have to understand one concept, that's the row and column operation on the matrix does not change the determinant value of that matrix. Okay, that's the only concept we need to know. Okay, so I think the first option looks little complicated, so I am skipping to second option. In second option, the column, first column is remains the same. Let's look at the second column. Okay, this x plus 1, y plus 1, z plus 1. This was our actual second column. Now it's changed to x plus 1, y plus 1, z plus 1. So here we can write like in this section C2 is C2 plus C1, right? That is, when we add this column and this column, we get this column. Okay. Now, now look at this column, x square plus 1, y square plus 1, z square plus 1. It's nothing but this third column is added to the first column. Okay. So we have done two column operations on this matrix and we got this matrix. Since column operation doesn't change the determinant, this option B is giving same delta. Okay. If this is equal to delta, this is also equal to delta. Okay. Now look at the option C here. Okay. Here I can see 0, 0. Here I can see x minus y. Okay. So let's look at this row. This is x, this is y. So if I need to get x minus y here, what I am doing here? R1 is equal to R1 minus R2. Okay. If I do this, 1 minus 1, 0. X minus y here, x square minus y square here. Okay. Now look at the second row. So here y minus z. So R2 is nothing but R2 minus R3. So 1 minus 1, I am getting 0. Here I am getting y minus z, then y square minus z square. So this is also a row operation on this matrix. So this also gives same delta. Okay. This also gives same determinant delta. Now let's look at the option D here. So here I can see 2. Here x plus y. So this x and y added and we got x plus y. So in the option D, let's check the R1 is nothing but R1 plus R2. So we 1 plus 1 we get 2, then x plus y here, then x square plus y square here. So in similar way, R2 is R2 plus R3. That is adding these two, I am getting this. Then y plus z, I am getting this. Y square plus z square, I am getting this. So this option D is also a row and column operation. Okay. So these three options satisfy the given determinant value. So our answer is nothing but option A. Okay. So this is the correct answer for this question. Okay. I think you all got familiar with this subtopic determinants and familiarized with this gate previous year questions. Okay. So we can do more problems on coming sessions. So give your comment suggestions. Should I include more theory or I can uh, prepare problems on subtopic levels and come with more sessions. So you can suggest uh, your views. So I'll be coming with more problems. So thank you for watching this live session. Okay, bye.